Well, yeah. Okay, welcome to IP Tech Tuesday number 64. Today we're going to talk about protecting data. And before we start, we're going to, unfortunately, we'll take a moment of silence. We have hostages who didn't come home yet. I'm sure you've all heard the expression, the data is the new gold. And it makes sense because we're a knowledge-based economy. There's a lot of data. If you're talking about AI, you train it on data. And data is so valuable that Anthropometric was willing to risk $1.5 billion verdict on copyright piracy in order to get it. They lost. A lot of companies use data as part of their flywheel or moat in order to get bigger, better, faster, more efficient. Wherever we talk, you have data centers and you have data clouds, and 2% of the world energy is being used for data something. Data scientist is a very important, common, and new profession. Everybody is collecting data. You walk down the street, a camera takes a picture of you, gets data, it sends it somewhere else, and so on. And some data is, in fact, immediately valuable. For example, if you type a search into Google, the words you typed in are used as data to decide which advertisement to show you, and the minute they show you that advertisement, ka-ching, they charge money from the advertiser. So we have data everywhere, and it's definitely the new gold. And the question is, how do you protect data if it's so important for your company? Now, data is clearly some type of intangible or intellectual asset, but most of the IP laws don't even recognize that something like data exists. And definitely most of the laws were written before data monetizing was so powerful as it is now. Even if you think about IBM, they sold hardware. Microsoft changed it because they started selling software. And in fact, I think the pathway which data is taking is similar to the pathways that software once took. It used to be, a free for all. Then it became valuable, and then it became easier to protect it. The difference is, of course, that software is easier to protect than data, partly because data is even less tangible and is definitely less specific than what data is. What we're going to talk about today is how do we make sure that we, our clients, and only our clients, have the right to use our data, extract insights, monetize the data, whether directly and indirectly. And of course, we also want to own the applications that are built using these insights. And not only do we want to do that, but data is very dynamic. And we want to have procedures which allow us to change what we're doing to adapt to the changes in the data. But before we do that, there's something very interesting about data. There are no natural laws. I'll give some caveats later on. No natural IP laws for data. We all know if you have a technological innovation, you file a patent. If you know something that gives you an advantage, it's a trade secret. If you build the brand, it's a trademark. If you write a book, it's a copyright. Each one of these technologies has a natural law. And when we hear about one of these inventions or one of these improvements, we immediately think about that natural law. And in fact, some of my Tech Tuesday presentations was specifically about how do we use unnatural IP law in order to protect what you usually don't think about. What happens in data is because there is no natural IP law for protecting data, but I think we can agree that data is some type of intellectual something that has value, we can ask ourselves questions which are more difficult to ask for other IP simply because we get confused. For example, what exactly is the asset that we're trying to protect? How do we want to use that asset? Where does that asset, when is it at risk? Where are we at risk because of that type of asset? And only then do we ask which laws can be helpful to deal with any of these issues. And we also ask, and if you don't have laws, you think about it more, which practices do we have which can help any of these issues? Now, these questions have nothing to do with data. It's just easier to talk about them when we have data. So the conclusion that I came to is that IP is about control of intellectual assets. When you have a regular property, let's say this fan, it's very easy to control. It's in my room is locked at night. That's physical control. Intellectual assets are not physical, and they're really not easy to control, mainly because, except for know-how, they're very easy to copy and duplicate and transmit and derive from one place to another. So the basic issue of IP, which we should be applying to data as well, is how do we control the data? And the most basic type of control is controlling the asset itself. And the easiest type of control to talk about is that we don't have leaking, that other people can't get access to it. And if other people can't get access to it, the asset is safer, but of course, other people could recreate it. The next level of control is not only other people can't get access to it, but it can do what we need to do. Okay, like a hammer, I can use it to bang in some nails. And under that is the question, are we free and able to use this intellectual asset for whatever end we have? And of course, one of the common ends is licensing. Then we have weaker control, which is basically we allow people to have access to it, but we somehow limit other people in what they can do. Why do we do it? Because we get money, we shape the ecosystem. We still want control, so we don't lose out and are not left behind. Another type of control is preventing the asset or the uses of the asset from being damaged. And last but not least, part of control of an asset itself is not letting other people control our assets. An interesting property of intellectual assets is that once you have an asset, you modify it, you build another asset on top of it. And another type of control we want to have is either preventing other people from building assets or obtaining control of any assets, intellectual assets, that they build on top of this one. In addition, intellectual property is also about controlling things that are not intellectual. For example, we want to control the IP, I know that is intellectual, but of others. Maybe we want to dominate the IP. What I just said before, we don't want other people to control us. We want to control them. Sometimes we want to control the competition. A direct way of control is using trade secrets. If I have a secret, you can't do what I'm doing because you don't know how to do it. Another way of control is using threats. I'm going to sue you, or I make you an offer that you can't refuse, like standard essential patents. Or even we do cooperation. I give you an asset, it helps you do things. There's indirect control. For example, if I have two solutions and one of them I keep to myself and one of them I give out, people are naturally going to do solutions of the type that I gave out and not the ones I kept for myself. The Chinese in the book 36 Strategies talk about killing with a borrowed knife. Basically, it means causing other people or the tools of other people to do the work that you need. That is, of course, something that we want to do with IP, but we're not going to go into it today. We also want control of non-IP, which is built upon the IP. The easiest way to do it is you have a patent and people do not have permission to do whatever they want to do in the real world, build a machine, sell a machine, without your permission. The control has to be at the right place and the right time, should be. And let's say the right time and place is when the IP can have an outsized effect. And one of the times that IP can have an outsized effect, we can call it control points, is when people make decisions. And guess what? People make decisions using data. We want to make sure that they have the right data to make the right decision. Right means, what's good for us, not what's good for them. And when we talk about right time and right place, data is always changing. Last but not least, and I gave a whole talk about this, maneuvering room. One of the things we do with IP is we control the world, competitors, in order to give us time and space usually means market, to build a different moat, which will do the work and not IP. Okay, this is general. Let's talk about data. Okay, going back to data. So what is data? It could be lots of things, but I'm focusing on, let's call it relatively raw data, like whatever your Apple Watch collects. And I'm not including knowledge and insights and all these other words, which really mean that somebody has taken the data and understood what's going on. Most ways of protecting data are indirect. I'm going to talk about it later, which means that the context is very important because you have to know which indirect way can work. It also means that you have to figure out where data fits into whatever it is you're doing. So where does it come from? Where does it go? How does it flow? What makes your data vulnerable? You have data, it's intellectual property. Where is it vulnerable? IP in general is usually not used by itself, and we can ask the same thing about data. Will it just be data, pure data, or will it have something with it? And what are you going to do with the data? Depending on what you want to do, that's how much control you might need. And last but not least, and we're going to talk about all of these things in the next few minutes, when is the data valuable, and to who is it valuable, and how is it valuable? And the question to you as a person in charge of protecting the data is, what are these other people going to do in order to obtain the data if it's so valuable for them? Are they going to steal it? Are they going to reproduce it? Get back to exactly this point. What gives data value? First of all, who is it valuable to? It's valuable to your competitors. It's valuable to your potential licensees that you want to license the data to. It's valuable to your customers who buy the data or products based on the data. And the question we ask is, how valuable is it to each one of these actors? Is it so valuable that it's critical, they can't run their business without it? And when we talk about data, and you probably think I'm talking about our data,
in der Moat.
we also want to control.
Hast du mal geguckt?
We also want to control their data.
Das geht nicht.
Second, what? We also want to control the data that belongs to other people. And we also want to control the processes that they do, which are based on data. I mentioned decision making. Okay, fine. Data is valuable. We know how valuable it is. Next question is, when is that data going to be valuable? And perhaps just as important, how much data do they need for this value? It's very common, for example, in machine learning, that you use X amount of data in order to get something that works, and 10 times X in order to get something which is, 10% better. So if somebody could only have 5% of your data, is that enough for them? We have to prevent them stealing even 5%. Sometimes they need, 50% of your data. When do they need the data? All we have to do is make sure they don't have access to the data when they need it. And data is usually not provided as a bulk unit, but as a stream of data. Well, what rate of leakage is meaningful? What rate do you care about? What rate do you have to protect? These are very complicated, multidimensional questions. And one of the ways to deal with questions like this is to do scenario analysis, which doesn't mean I figure out what scenario is going to happen, but rather I devise a scenario which has some interesting things happening in it. And I analyze that particular scenario. And by analyzing that particular scenario, we get a better understanding of the issues which are involved. Eisenhower, I believe, said, it's not the plan, it's a planning. Because the plan that we made is not going to happen, but the planning process helps us understand what we can do and what we can't do. Law. Do you have direct protection of data? I'm saying not so much. In Europe and a few other countries, you have a database directive which says that you're not allowed to copy other people's databases, even if they're public. But there are all sorts of limitations. And I quoted on the side the beginning of the database directive. It says where databases are not properly protected. Now, is any data a database? No. There are other limitations, and these are also territorial protections. You don't get protection in a different country for what? In some cases, okay? This is all the law is country dependent. For example, the US does not have a database directive because the law does not allow the copyright law to apply to databases. TRIPS, on the other hand, does say that you should give protection for compilations of data. In the US, on the other hand, if you take data and you have a human intervention, you probably need less human intervention in order to make it copyright protectable. To even things out, I mentioned the EU Data Act, which came into force, I believe, 4 days ago. And the EU Data Act talks about control of data by the users who generate the data. Okay, I'm sure you know if you own a tractor and you drive it, the tractor keeps track of what it does and it sends all the information to the tractor manufacturer. What if you want to take the tractor to be repaired? They would like to have access to that data. It used to be that you couldn't. So the EU Data Act says that the owner, let's call it, of the tractor can get access to that data. Why is that important? because it means that as a tractor manufacturer, if you believe that data is critical, this law says that you don't have control over it. All of your users can sell that data to somebody else as well. Obviously, data can be kept as a trade secret or as confidential information, and data which is supposed to be public, that's not very useful. Commercial laws. I'll just point out unjust enrichment, which I saw a recent case in Japan, which appears to apply it. If somebody uses your data, then they should be punished in Japan for using it because it's not fair. And the big thing, of course, is contracts and agreements. You can write a lot of things in a contract. It's more difficult to enforce, but I can write a contract saying that one of you can use my data, but only for looking at and not for making a sculpture. And we're going to get to that in a second because that is a very important data issue. Luckily for us, data is not just an object, but you actually use it, and it has a life cycle. And what we're used to doing in IP strategy is look for a weak link. And the weak link is not necessarily the product, but something else. We all know that you can't write a patent on an idea, much as our clients would like to. And yet we manage to protect ideas fairly well using patents on implementations of the ideas. So, but before we go into that, I'm reminding you that if there's enough human involvement in the data, in selecting the data, in processing the data, in collecting the data, whatever, it could become an authorship by that human. Hopefully that human signed a contract with you so that you own the data, but then you get copyright law. Any case, data has a life cycle. It needs to be generated. It needs to be processed. If you want to use the data, you usually have special algorithms or structures, whether the data structures or actual physical structures. And all of these things, of course, can be protected using standard IP protection things. So if instead of looking at the data as such, you look at how the data is used and how its life cycle changes, you can often identify a few spots where you can use existing IP laws in order to control the use of your data. We give you some examples of IP laws and where you can use them for protection. Patents. How do you generate data? How do you collect data? How do you clean data? How do you train AI using the data? Data that's embedded inside a piece of hardware and they work together. Insights that are operative, meaning you're doing something different because you have an insight. How other people use your data, specific architectures for that data, specific components, electronic or otherwise. Downstream uses, ripples, that's a different product that comes into existence because of whatever it is you're doing. Specific applications. We've written patents about all of these. But if you think about data, you can write it in a way which will block use of the data. Trade secrets, of course, all of these things can be kept secret, but the data itself can be kept secret. Negative knowledge, what not to do. Very valuable trade secret, protected. Specific insights, which are not operative yet, but they help you understand what to do. Future data, mental methods and procedures you use in order to understand data and process the data, okay? I'm especially saying mental methods, not protectable by patents, yes, protectable by trade secrets. Know-how and team-how, which is kind of like culture. How do you deal with a particular type of data, like automotive data or GPS data? How do you deal with particular data sources? For example, Visa is an expert in dealing with data interfaces with multiple payment systems worldwide. Okay, none of it is secret, but how to do it is not only know-how, but actually they have a whole culture built around it. What is the statistical or other behavior of the data? How do you take that data and help it work together with AI systems? What dynamics do you expect? What is your attitude towards the data? Do you trust it? Do you not trust it? And so on. All of these can be protected under know-how, and if the know-how is not secret, you protect it by keeping the people with the know-how by you and not training other people with the know-how. Copyright. Whenever you have significant human manipulation, even on only part of the data, copyright can exist. Contract. Super duper important. The other way around. Whenever you have a contract, you have to ask yourself the relationship. What data will happen in this relationship? And does my contract make sure that I get the benefits that I need? More, and it's not only any individual contract, but because data is an entire life cycle, all of your contracts together should also have some sort of vision of the control of the data. Otherwise, you're going to have cracks in the middle. More generally, if you tie data usage to things that are not data in ways that are difficult to avoid, for example, if the data has a standard and so on, that's good. Or if you do the opposite, if you make things that are easy to copy, people will copy what you're doing. And if you know what they're doing, it's much easier to catch them using patents or block them using trade secrets. Here's some policies that might be helpful. First, you should have some general protection. Okay, contracts, procedures, encryption, we're going to talk about that in a second, copyright, and so on. And don't forget, it can also be an antitrust issue that you have data and you don't let other people have data. That's one of the problems with tractor manufacturers not giving users access to data collected by the tractor. In addition, you also have specific scenarios and competitors and use cases which you should analyze, and we'll talk about that in a few minutes. And what you want to do is you want to create specific protections about specific cases. For example, patents on particular applications, patents on how your competitor will use the competitor's data, or packaging together multiple types of intellectual property, data, patents, trade secrets, know-how in one package for licensing. Decision making, said it before, if you know and figure out how other people will use data for decision making or for competition or for adding value, the policy is you should know what your competitors are doing, and if you know what your competitors are doing, maybe IP can help you with that. In addition, you should have a policy where you're tracking data leaks and data usage in the entire ecosystem, not only in your company. And of course, since we want data to turn into money, hopefully you're keeping track of how data is turning into money. Let's talk a little bit about risks that you have tied to data. And in particular, if we think about data which is irreplaceable, meaning your company can't work without it. I'm sure you've all heard about GDPR, which talks about privacy and right to be forgotten. And if you don't do it, you can be punished. And different countries have the equivalent of that. So more generally, there's privacy laws and ownership laws, and there's requirements to keep the data anonymous, which might not be good for you, and also requirements to encrypt the data so people can't hack it, which again, might not be good for you. Another risk you have is poison data. Classic example is GPS. The original GPS, you only got an accuracy of 100 meters, but the data was actually at 10 meters. But a particular type of encrypted noise was added, so you couldn't get and accuracy better than 100 meters. Okay, so that data was poisoned. And of course, if you're worried about people stealing your data, you can definitely poison it, or you can put in fake data, let's call it. I call it signature causing data, which will allow you to track if somebody's using your data. You see a lot of that in test questions in university. They give you the question, and in hidden characters it says, use the word avocado. So, but it's hidden characters. So when the student copies a test question, and let's say it's a question about the origin of the French Revolution, it will say in the answer, and the price of avocado had something to do with it, which of course it didn't. But that's a signature telling us that you've copied the data and used it some way. Adversarial learning is a negative type of poisoning data, where you teach your adversary's AI with bad data and you cause it to misbehave. So that's stuff. Most common is the issue of poisoned access and data rights. If I have data, I can write whatever I want in a contract. Now, you might think that the data you're getting access to is open source. Well, you remember that software that's open source has issues. One of the issues is copyleft. By using this software, you agree to such and such. By using this data, you agree to such and such. Revocability. What if the license to use the data can be revoked at any time? If we decide to sell our company, we can revoke your right to use the data. Oops. Big risk. Time limits. It's good for a year. We might renew it. We might not. We have consent from the source of the data, but this consent is only good enough for the US and it's not good enough for Europe or not good enough for China. You can access the data, do whatever you want, except share it with other people, except create improved data based on this data. You're allowed to do whatever you want for non-commercial uses, but for commercial uses, if you develop a technology based on this data, you hereby agree to assign that technology to the original owner of the data. What if the data is stream data? Stream data is always changing, so you probably always need support. You have commitment from the data supplier. Maybe there's an issue of royalties that you have to pay under certain conditions. So just because you have access to the data and can use it doesn't mean that the access is not poisoned in a way which gives you a lot of risk or gives other people rights over the data which are not acceptable for your company. Solutions? Well, first of all, it's always good to have replacement for irreplaceable data. Second, you need to remember that these risks are big and not small. There's this concept of fruit of the poison tree. You use something you weren't allowed to use. Anything that comes of it is bad. Same way, if you steal data, or not intentionally, heaven forbid, but a worker comes and they use data which they took from their previous employer. So I call it a solution, but yeah, you have to make sure that you do have the right to own, use, and control the data. Contracts. Laws are changing all the time. Well, we've talked about some things. Now look at it from the other side. We have a competitor. We might be able to use other IP tools to prevent our competitor from obtaining alternative data. So they have to continue using our data. And we have to have some solution to prevent siphoning of data. I just gave you the example of the Data Act, which says that the original users that created the data are allowed to get control of it. How are we going to keep them from taking that control and selling the data to our direct competitors? The answer could be using patents. antitrust, and so on. We'll get there. Is data itself a moat or a source of competitive advantage? Well, sometimes it is. If I'm the only one who knows what is the shoe sizes in a certain population, then I have a huge advantage over my competitors who don't know how many shoes to manufacture of each size. Data can also be used to build a moat. I mine the data for insights, and I use the insights to design a better system. Or maybe for writing patterns. We do a lot of that. Test translations should be transactions. When you buy data or data report or do a pattern search, what you're doing is you're trading data for money. Data is more commonly used as part of a business relationship. Think about the stock market exchanges, they generate data. And then another company like Bloomberg buys that data and does stuff with it. Everybody enjoys. Classic example, Apple and Google. Google pays Apple $20 billion to be the default search engine so that Google can get data from Apple devices. Apple, of course, first made sure that no data escapes Apple devices so they can charge sending data. Let's take two examples of building an entire ecosystem around the data, GPS data, Nielsen rating for TV usage. It's a bit defunct now, but still, a whole ecosystem of what to do with and for that data. Data asymmetry can definitely be used strategically, and I have here two examples. One is high-frequency trading. If you get access to the data 100 milliseconds after me, I'm going to beat you. And in the Count of Monte Cristo, the Count used fake data to cause Danglars to go bankrupt. Okay, so he knew things that he didn't know. It's great. When we talk about data, we can talk about different types of data based on how the data is used. Operational data is data you use to operate your business. Usually it's less valuable to other people unless they're using it in order to cause trouble. And usually you protect it as trade secrets. A completely different type of data is substrate data, like the stock market data. Okay? You trade it. And if you keep people from having access, it can kill a competitor, or if you give that data, it can feed an entire ecosystem. And this data can very easily leak. And I'm not going to talk about technological solutions which limit access to the data. Exhaust data is a very important type of data. And let's say I'm doing something, for example, Waze is collecting information about the location of cars. Fine, we know they're doing it, they're using it for their own good, but they also publish it. And I heard a great example of the bus system here in Israel, where every bus has GPS. And by government mandate, you have to put that data in a central server, which is, of course, impossible to read what it has. So somebody put up a service which allows you to access that data with the thinking that people want to know when the next bus is coming. And a whole ecosystem sprung up around it. The problem with exhaust data is whoever's generating this exhaust might damage it completely unintentionally. They change the format, they change the timing. And if you're using exhaust data, it's very useful if you have a contract with the person generating it, which requires them to keep on providing it. One more type of data is growth data. That's data that you use in order to grow, in order to get bigger, to get better. If it leaks, you don't notice it at the beginning, until you discover that your competitors are keeping up with you. So you have to treat that kind of data differently. I don't know what you were thinking about when I keep on using this word data. Maybe you were thinking about big data. All of the locations of all of the cell phones that are on or off are being used right now within 100 miles. Big data. But also small data can be valuable. You know, when you have small numbers like 10, 20,000 pieces of data. And one of the reasons is because each individual data might be higher quality or more valuable to obtain. And I think a great example is the difference between training an LLM and using distilling. Training an LLM, you have to steal all the books in the world and teach them to the LLM. Distilling, you just have to ask somebody else's LLM 50,000 questions, and then your LLM can be nearly as good. I mean, that's the way it was, you know, a year ago. Today, it's different. So there's big data and there's small data. Sometimes the data is a bulk item. Like I said, all of the books in the world, it's a very big item, you get it once. But sometimes it's a stream. I mentioned locations of cell phones, they keep on changing. We need to protect the stream itself as a stream, but you also need to protect the new data because the old data probably has less values than the new data. You might have what's called a data factory, some sort of component which generates this data, a sensor in your car, which measures, I don't know, fuel consumption. Some data is created artificially, which of course means you can't get copyright protection. And I think the best example is a Go Zero. A Go Zero was a project where they taught AI to play Go, but they didn't teach it anything about Go. They only let it play against itself. So it simulated itself and simulated games and saw the movements. Everything was artificially created. It's a big thing in robotics because the time it takes a robot to move an arm, we can run, I don't know, 10,000 simulations of what the movement can look like. But like I said, copyright and ownership is a bigger problem here. We talk about data, it can be raw data and it can be clean data. Raw data might be easier to protect technically, and clean data might be easier to protect legally. So what gives data value? Well, first of all, if you're the only one who has that data, part of the value is how long does it take other people to obtain equivalent data? And this gives you time to build your moat. If you have better data, the question really is, does this betterness really give you a significant advantage? And if it does, somehow you can use IP tools to protect the advantage rather than the data itself. When you have, I call it a closed data scheme, you're the only one providing the data in a certain way. You can use IP to make sure that people that want to use the data use your tools to access the data, and other people can't build tools because they'd be infringing your IP. And therefore, it causes your buyers, your data buyers, to have difficulty moving to a different supplier. Sometimes data is a commodity. That's more difficult, but maybe we can use IP to add some friction, to cover ways of adding value, and so on. Talk about data, and one of the differences between data and software has to do with fungibility. Sometimes, if we talk about knowing how many people wear what shoe sizes, so I can start off with a database with 100,000 people and the shoe sizes. If I leave the database and one of you goes into the database, the data is just as good. But if we have data in particular about people who like wearing sandals or patent attorneys, it could be the data is not fungible. So you have to ask, what am I trying to protect? The statistics of the data, individual datums, data as used in a particular market, and so on. Talked about weakness. Flip side of weakness is vulnerability. The company structure might be vulnerable. We don't know of any weakness, but it is vulnerable. If I have a critical processing step, there could be a freedom to operate problem in applying it. If I'm a transparent organization, my competitor will know more about whether I'm infringing. If I'm based on data coming from particular suppliers, let's say Waze or Google or somebody else, what do I need to do in order to make sure that they meet with their requirements? Part of it is contractual agreements, but part of it can be IP. If it's individual customers, I have to make sure these customers continue supplying me with the data. If you're selling the data and your buyer doesn't have freedom to operate, then either they won't buy it from you or they'll pay you less money and the person that's infringing more money. So it's useful to make sure that the use of the data is not vulnerable either. What I'm suggesting is to do a data audit. The data audit, we look for leaks where you can lose control of the data, legal leaks where you have problems with data rights, even if you're not actually now losing control of the data, blockages where you can't use the data, and places where you might want to have more control of the data. So the biggest leak, and we see quite a bit of it, is that people build a product which generates data, but they don't collect the data, or they don't own the data, or they don't make sure they have exclusivity of access to that data. And one way to deal with it is mapping out the flow of the data, both inside your entity and outside your entity. And what's happening inside is important for you to continue existing. And what happens outside has more to do with competition, monetization, and control. And then we look for stuff like, where's the data transformed? Where is it used? Where can people distill the data or otherwise reverse engineer it? Where can people use alternatives to the data that you have control over? Where do you have critical nodes or pathways that can be blocked or monetized or siphoned away? Where do you have legal risks added? And one thing which I do not know how to do, where in the entire data flow can we put down a pin that our investors or competitors can easily understand that we have real data protection? Okay, data is data. How do we say nobody can steal our data, nobody can use it? So I made here a few examples. Selling data together with a proprietary format and software for processing, generating a stream of data to be sold to other people, using data to build the first product. Now, each one of these is examples of companies we've worked with that use data, using data to train a machine learning model, but it doesn't have to be that data. Bootstrapping, you have a version 1 product, you're going to collect data and build version 2. But maybe you won't have enough money to get there. You have to convince people to give you money based on version 2, which doesn't yet exist, because it needs data which version 1 hasn't yet supplied. And data processing itself is a commodity. And it's tricky, but we do have clients which manage to leverage their IP so that even though the processing they're doing appears to be a commodity, it actually has significant added value and people pay a premium for it. So what you do now, you just heard me talking for about 50 minutes about data. Most important thing you should do is commit. The data is valuable and it needs to be protected. Yeah, and monetized and leveraged and also tracked. The next thing you should do is do a data audit and identify what your data is. Now that you've done these, step 0, figure out how your data is valuable to who and when. Then identify critical junctions where the data does something or we do something to it. Look for weaknesses and vulnerabilities and plan what to do about them. Next step, make sure you have agreements and contracts where needed, including checking the existing ones you have. Now, you should actually start controlling your data. And last but not least, we've done things for ourselves, figure out how we can use data and IP syncing either to work with your competitors or to win against them. In conclusion, data is valuable. Doesn't really have good IP laws, but we talked about all sorts of ways we can do. And in particular, we leverage it generally like maybe ideas can, but it's different. And there's lots of different types of data, and the data is dynamic all the time. And your company is dynamic, so what it needs is also changing all the time. I just gave you an example about a AI barber, and they suddenly want to collect data and sell it. Everything we spoke about just now is relevant to them. I am stopping the recording.